This video will give you an overview of our mastery project, the hoop glider. I want you to try to re-engineer it, redesign it, test it again, and make it better than it was before. Now, do keep in mind that you're going to need to make some sort of report. This can be a written report, it can be a slideshow, it can be a video. We'll talk more about it during class, but your overall goal is to convince the observer, the reader, that your hoop glider actually flies better based on your new design. So you need to keep very careful records. You can make pictures, you can make sketches, you can make measurements, make videos. All of that's going to have to be summarized in some sort of report. I don't want to chronicle, I don't want to book here, we don't want a major hour-long production, but you need to keep records and then present it in some sort of summary form to convince the observer that you really have re-engineered a better hoop glider. So specifically, here's what I want you to do. You made your original model. You should have the dimensions of that, and you should have measurements of how well it flew. I want you to pick one thing to change, one variable about your hoop glider that you can change, with the goal in mind of trying to make it fly better. Now, you made some observations of it. What do you think might make it fly better? Now, I know you don't know very much about maybe how it's flying, and that would really help in the redesign process. But our main goal here is not necessarily to design a fabulous hoop glider for everybody in the world to use. It's for you to learn how to do science and engineering by changing one variable at a time and controlling the other variables, and then remeasuring and comparing measurements. So it's about the process. So keep all your other variables the same and only change one thing. Now, if you want to change the size of the rings, for example, let me suggest that you only change one ring, then retest. If you want to change the other one, fine, retest. But only make one change and do test between changes. Remember how when I ask you to go out and fly your original glider, I ask you to practice first. You should do that with your modified glider. Don't go out and just measure the very first throw. Make sure you know how to throw it. Try to do it the same way that you did your original, unless you think maybe there's a better way now based on your redesign. So when you think you can throw it successfully, make 3 displacement measurements, at least 3. You can make more, and record that data, and then I want you to compare your averages to see if the changes you have made makes your model fly better or worse, and you need to be honest about this. So your original model had a certain set of dimensions and followed a certain pattern, and you threw it in a certain way in a certain place. That's going to be our control. Your job is to try to think of a way to make it fly better using scientific methods or an engineering design process. You don't have to follow a specific series of steps. The main goal is to show that your model does fly better than before, and that it can be explained by the changes that you made. So if you change 2 things at a time, for example, you can't explain whether it's working better or worse due to one factor or the other, because you changed 2 things at once. If you go outside on a windy day and your original model did not have wind, then again, that's a variable that's changed. So you may change, say, the size of the ring and have wind assistance. That's 2 variables. You need to try to control for that as best as you can. So, bottom line, pick one thing to change, retest at least 3 times so you can have an average. Recalculate that average displacement and compare it to your previous trial. Now, what should you change? That is really up to you. There's all kinds of variables that you can test, and it doesn't matter to me what you do as long as you make measurements, document like pictures or sketches, and go out and retest and try to control all the variables except for that one change. It's the process that I'm looking for here. Just as an example, I found that if I put a paper clip over the small looped end, that mine flew better. However, when I was originally testing mine, I was actually standing on an elevated surface up on my deck in my back yard. So if you're on level ground, that may not be a good modification for you. Test it out and find out. Now, this is really important. When you make one change, you go out and retest, you compare to your original model. Okay? If it flew better, that's great. If not, go back to the original and make one change to the original, not one change to your modified one. At least not unless you have a really good reason to do that. Okay? So in other words, if you make a change and it flies worse, then don't change that worse model, because the chances of you making it better seems very small, unless you've got some really good reason for it. If you can say, oh, I see the problem, try to fix it, that's fine. But document that. Document why you do that. Write this down somewhere. I'm not going to ask you to turn in your notes, so how you document it's up to you. But all I want from you, basically, in the end, is a summary of your data in some sort of presentation form. So if you can think of any reasons why the model was more successful or not, you may want to make a note of that to yourself, because that might influence your future designs. Also, I'm asking you to compare averages, your average displacement, but what if one of your flights of one of your new model really flies better than anything that you've seen before? You may want to stick with that design. Maybe the average wasn't better, but that one long flight shows you that you were on to a promising sort of change. You may want to follow up on that. So again, if your modified model flew better on average than your original, then make your next change based on the modified model. But if your original model flew better on average, you may want to go back to the original and make a different change to try. You know, it's back to the drawing board. Make sure you practice between each trial. Don't just go outside, throw it 3 times and say you're done. Because you practiced the first time, you made sure you knew how to throw it. You should do that for every trial. I would like for you to do at least 3 changes. So again, if your modified model flies better, then keep on changing it. If it doesn't, then go backwards a step and try something different. Let's try to keep safety in mind, folks. You need to have a safe place to do this. You need to do it at a safe time. Do not go outside in the dark. Don't go outside in the lightning, okay? Don't go out into the middle of the street. Don't throw it at people. Don't throw it at dogs and cats. Please be safe out there. I can't monitor your behavior, and so I'm just going to depend on your good judgment. But remember, safety first. You may not be used to such an open-ended project. It may sound like I'm not giving you enough direction, but I want you to understand. I want you to take ownership over this project. And I want you to produce a project that you're proud of. I want you to make something for your backpack that you can put in there that you're really proud of, that you might want to present someday to, say, an audience and show them that you can take something with very little direction and make sense out of it. Okay? So this really is really open-ended. If you have a different idea about what you want to do, contact Dr. Kemp. If you have a different idea about how you want to make your presentation, contact Dr. Kemp. This is really, really open-ended. Whatever you made a note of on your original throws, about wind and the way to throw it and so forth, you may want to make a similar set of notes on your original model, your modified models, and I want you to try at least 3 modifications, at least 3. That's a minimum, okay? You can change it as many times as you want until you get it to the level of satisfaction that will make it, up to your standards. So please, folks, take this project, do the best job that you can with it, make a good report from it. It's going to be a mastery grade, but more than that, I want it to be something that you're proud of. You are in charge of your learning. Learn from this. There's all kinds of things from how to do science or how to do engineering to how things fly to just how to make a presentation, how to record data. There's all kinds of things you can learn. Take this opportunity and run with it. All right, if you have questions, please contact Dr. Kemp at any time.